Alright, so you can just pause the recording on this for as long as it takes for the students to check their homework. I told them to skip numbers 1 and 2. I didn't tell my first 3 classes that, but just tell them not to grade those. Numbers 3, 4, 5, and 6, I showed how to set up the equation and then what the answer should be. How to calculate your grade, I didn't do it exactly what we should do for each point-wise, but this is how I want them to calculate their grade. And then write on their postcard and pass up. So you can pause this at any time for them to be able to watch this. I'm going to get started on the lesson. Okay, so multiplying decimals by decimals. Yesterday we did dividing decimals by decimals, and you should have those notes in your composition notebook. This is the same sort of style of notes that we're going to be taking today. Okay, so our example, we're going to start off with a really easy example, and then we're going to get into a little bit more difficult ones. But our first example that we're starting off with is 0 and 6 tenths times 5. Okay, so our first step is we're going to set up our multiplication problem vertically. So step 1 is to set up your problem vertically. All right, so whenever we do that, it's going to look a little something like this. Pretty simple. Our second step will be smart bird's not getting along with me, which is what's new. Our second step will be to find the total amount of numbers behind the decimal point for our problem. Okay, what I mean by for our problem is everything above this line right here, everything above here is what we're going to find our totals. We're going to add them up. So let me rewrite this down here. So we have 0 and 6 tenths times 5. So 5 doesn't have any numbers to the right or behind our decimal point. We only have our 0.6 behind it. So our total number for this example, again, this is a simple example, is we have 1 number behind the decimal point. Okay? So step 2, find the total amount of numbers behind the decimal point for our problem. Then I want you to write it to the right and circle it. This is just going to help us stay extra organized. So step 3 is to multiply like normal, ignoring the decimal points. Okay? A common mistake is that people try to line up the decimal points. That's for addition. This is multiplication, so we do not need to do that. So we're going to multiply like normal, ignoring the decimal points. If you want, you can rewrite the equation without the decimal. Just you have to remember to have your circled numbers. So let's do that. So we have 6 times 5 if we write it without the decimal, and I have a 1 circled to the side. 6 times 5 we can do on our head, and that's 30. Okay, so we get our solution. Now our fourth step is going to be to use your circled number to tell you how many places to the left to move your decimal point. So we're going to move the decimal in our answer to the left. I'm going to bold left because it's important to know which way to move it. So we're going to move it to the left. However much, whatever her number is that is circled. So we're going to move the decimal in our answer to the left, whatever our circle is. So we're going to move the decimal to the left. How do I want to say this? The amount we circled. Okay, so we have 6 times 5, we got our answer to be 30. Right, we had a 1 circled. So this 1, if the answer is 30, I have to realize that my decimal point is right here. And this 1 is telling me that I need to move it 1 place to the left. So that our answer for 0.6 or 0 and 6 tenths times 5, our answer is 3. Now let's see if that makes sense. So we're multiplying by a number. This number is greater than 1. So whenever we multiply our first number by a number greater than 1, our solution should be bigger. So from 0.6, is 3 bigger? Yes. So that makes sense. Okay, so let's move into some harder examples. Remember, these are the notes that I want you to have out and use whenever you're going over classwork or anything else like that, such as homework or studying. They will help you, I promise. My last step that I want to add before we do the other examples, I'm sorry, I almost forgot. This will be step 5, is to check for reasoning. That's what I just did before, but check for reasoning. So the same step that we had yesterday. So we can either estimate, but whenever we have really small numbers, it's easier to just estimate or use our number sense, which is what I have written on the board in the purple. And how I said multiplying by a number that's greater than 1, our answer should get bigger. Okay, so let's do our harder examples. We're going to switch colors. Let's do blue. All right, so my example 1. We have 0 and 52 hundredths, and we're multiplying that by 2 and 1/10. Okay, so let's think about it. We're multiplying by a number that's greater than 1. So should our answer get bigger or smaller? Your answer is that your answer should get bigger because we're multiplying. So it should get bigger. So our answer that we get should be bigger than this. Let's see. So our step 1 was to set up our multiplication problem vertically. So I have 0 and 52 hundredths times 2.1. Notice that I didn't line up my decimals. That's only for addition that we have to do that. Now, I'm going to write up to the side the total amount of numbers that are behind the decimal point, or to the right of the decimal point in our problem. So above here is our problem. So for 0 and 52 hundredths, there's 2 numbers behind the decimal point. For 2 and 1/10, there's 1 number. And we want to know the total for our problem. So that gives us 3. So 3 is the one that we're going to be using. Now, you can either rewrite it or just multiply ignoring the decimals. I like to just ignore the decimals, but if you wanted to rewrite it, you would rewrite it as 52 times 21, and you would just remember the 3 circled over here. So, if I do, I'm going to multiply just like normal. I'm going to do 1 times 2 and we get 2, 1 times 5 and we get 5, 1 times 0 and we get 0. Now I finished with the 1, I add a 0 for place value, now I move on to the 2. 2 times 2 is 4, 2 times 5 is 10. Carry it over here. 2 times 0 is 0 plus 1. And then I add. Just like regular multiplication. Now, this is where I start to use my 3. I bring it down here. My decimal point always starts here, and I go 3 places to the left. So my answer is 1 and 92 thousandths. Now let's check up here. Did it get bigger? Yes. So we know that we're right, or at least in the right direction. Okay, so I have one more example that hopefully we'll be able to get to. If not, this video is posted on Edmodo and you can watch it at your own time. So my next example, we have 27 and 43 hundredths times 1 and 89 thousandths. So I'm going to write it vertically. I have to find the total numbers to the right of my decimal point that are a part of my problem or above this line right here. So for 27 and 43 hundredths, I have 2, and then down here I have 3. So total, I have 5. Now I'm going to multiply just like normal. I'm going to move it up to give me some more room. So 9 times 3 is 27. 9 times 4 is 36 plus 2 is 38. 9 times 7 is 63 plus 3, 66. 9 times 2 is 18 plus 6 gives me 24. I finished with the 9, so I cross it out and I add a 0. 8 times, I need to cross these out up here. I'm actually going to erase them to help us not get so confused on the smartboard. So, now I'm doing 8 times 3 is 24. 8 times 4 is 32, plus 4 is 34. 8 times 7 is 56, plus 3 is 59. Hopefully I'm not making any math errors. 8 times 2 is 16, plus 5 is 21. Now I'm going to cross out my 8. Once I cross out 2 numbers up here, I have to add 2 zeros for place value. Because this next value is a 0, and multiplying 0 times anything is going to make it just be 0. So that would be a whole row of just zeros. So I'm actually going to just cross out that 0, and now I have 3 numbers crossed out, so I need to have 3 zeros here. Now I'm multiplying 1. 1 multiplying up by the above numbers is easy. Now I need to add. So see how important it is to be neat and organized and make sure that I have everything vertically lined up well. So now I'm going to add, and I get 7. 8 plus 4 is 12, carry the 1, 11, 9, 4 plus 1 is 5, plus 9 is 14, plus 3 is 17, 4 plus 4 is 8, 7, 8, 9, holy smokes, that's a big number. But we have to remember this 5, so I'm going to bring it down here. My decimal point always starts here, and I move it to the left. 5 place values. So that's 1, 2, 3, 4, 5. And my answer now is going to be 29. And holy smokes, that's a big number. We usually can just round to the thousands place, if not the hundreds place. So in that case, we would have 29 and 87 hundredths. That's an answer that I would accept. All right. So let's just check and see. So I'm multiplying, we're checking for logic now. I'm multiplying 27, let's change colors, 27 and 43 hundredths times a number that's a little bit bigger than 1. So I expect for my answer to get bigger. But it's just a little bit bigger than 1, so I don't expect it to be that much bigger. So going from 27 and 43 hundredths to 29 and 87 hundredths seems like it would be a pretty good bet. So we just checked our logic and that makes sense. I have a few extra problems that we could put up. I have a feeling that the class is almost over by now, or that we are done. The other problems that we can have students work on, I will put this slide over to them, and you guys can work on these if you have more time. So it says, let's work some harder examples if we have time. The rectangle represents DeMarco's garden for each square foot. He needs to use 2 scoops of fertilizer. How many scoops does he use? So we have to remember to solve this one. You have to remember that your formula for area is length times width. So this is something that might be beneficial. You can also solve this problem as well as this one. The sub can pause this recording at any time so that you guys can just have it up here and work on it. Okay, I hope you guys have a great weekend, and I will see you all Monday. Remember, you have no homework.